Bonjour à tous et à toutes, dear guests and participants. Je suis heureuse d'être ici au nom de l'Université Laval, la première université francophone à avoir vu le jour en Amérique. L'Université Laval figure au 14e rang mondial du classement d'impact du Times Higher Education et détient le prestigieux statut platine du classement Star en raison de ses engagements, ses réalisations, ses actions en développement durable. Notre université est carbone neutre depuis 2015 pour ses émissions directes et elle s'engage d'ici 2030 à réduire de 70% ses émissions par rapport à 2006. Alors, je peux donc le dire d'expérience, le chemin vers la décarbonation n'est pas le plus facile à emprunter. La science et les constats de terrain confirment que pour réussir les projets de décarbonation, il faut absolument passer par les 3 volets de l'ESG pour réussir. D'abord, le E, pour environnement. Les engagements en matière de décarbonation se sont multipliés ces dernières années. Selon les recherches du professeur Olivier de l'Université Laval, les organisations qui lancent ces initiatives, qu'elles soient substantielles ou pas, sont confrontées à un problème de crédibilité. Les nombreuses poursuites pour greenwashing montrent les écarts entre les paroles et les actes. Pour réduire ces écarts et faire la différence entre les entreprises réellement engagées de celles qui ne le sont pas, nous devons avoir des données plus fiables pour mesurer nos émissions de gaz à effet de serre et ensuite démontrer qu'on les a réduites. Le problème, c'est qu'encore aujourd'hui, cette mesure est extrêmement difficile à faire, pour plusieurs raisons, comme la complexité de mesurer les performances entre les entreprises, l'absence de consensus international sur les normes à mettre en place et les engagements souvent flous ou à long terme des organisations. Des efforts doivent être faits pour que les entreprises, leurs clients, les gouvernements et les citoyens puissent y voir plus clair. Ensuite, dans le ESG, il y a le S, pour social. Nous avons tendance à négliger cet aspect qui est pourtant majeur. L'acceptabilité sociale de chacun de nos projets, qui passe bien sûr par la communication, les échanges entre nos communautés, nos collectivités, mais qui passe également par la justice climatique. Selon un rapport du GIEC, donner la priorité à l'équité, à l'intégrité, l'inclusion et la justice sociale peut permettre des mesures d'adaptation plus ambitieuses, ainsi qu'un développement qui est résilient face au climat. Mais un des obstacles à cette justice sociale, climatique, est le manque d'éducation, qui empêche les personnes les plus touchées par le problème de participer à la prise de décision. Il y a aussi le défi de recruter les talents. La pénurie de main-d'œuvre est de plus en plus alarmante au Canada comme en Europe. En France, on estime qu'1,8 million de nouveaux emplois seront créés pour les diplômés universitaires d'ici 2030. Ces diplômés occuperont un emploi sur 2 en France. C'est-à-dire à quel point les effets combinés des changements démographiques et climatiques, combinés à l'arrivée des deep tech et de l'intelligence artificielle, créeront d'importantes perturbations au niveau du travail, du marché du travail. Les universités et les entreprises ont l'occasion de mieux collaborer pour mieux préparer la relève. Il faut savoir que ces jeunes veulent de plus en plus travailler dans des entreprises qui respectent leurs valeurs environnementales, qui sont inquiets face à l'avenir et qui sont éco-anxieux. Enfin, le G pour gouvernance. Une démarche de décarbonation comporte des risques, vous le savez, des risques économiques, technologiques, sociétals, des risques de notoriété, ainsi que des risques géopolitiques. Chaque pays chemine à des vitesses variables vers la décarbonation. Mais chose certaine, les grandes puissances sont encore largement responsables des émissions de gaz à effet de serre. Selon un rapport des Nations Unies pour l'environnement, l'ensemble des pays du G20 contribuent pour 75% des émissions mondiales. Les opportunités sont grandes pour nous de poser des gestes significatifs. Surtout que de ne pas agir coûte très cher. Au Canada, on estime que d'ici 2025, les dommages liés au climat ralentiront la croissance économique de 25 milliards de dollars par année, soit la moitié de la croissance prévue du PIB. Alors, pour agir, la gouvernance est primordiale. Tout découle du leadership que nous exerçons dans nos entreprises et organisations, de notre capacité à prendre des décisions éclairées et éthiques, à faire preuve de transparence et de rigueur. L'action climatique est certainement devenue un enjeu si important qu'elle doit faire partie de nos plans stratégiques et inspirer toutes nos équipes. Now, in the ESG blind spot, there's sustainable finance, which is an important key to decarbonization. More people want to invest in companies with low greenhouse gas emissions that are socially responsible. Sustainable investment assets continue to climb worldwide. They represent near 36% of total assets under management, according to a study by the Global Sustainable Investment Alliance. This type of investment has proved to be solid, profitable, and crisis-resistant. I'd like to conclude by underlining the importance of including and involving universities in the decarbonization solution. Because our researchers develop knowledge that can be transferred to industry. Because we can upskill, Because we can upskill and reskill staff through short, targeted training courses, in addition to training tomorrow's talent and sustainable development, one of the keys to a successful energy transition, and because we can help dissemination the most up-to-date information on the climate, I sincerely believe that to accelerate decarbonization, companies and universities need to work together, because it's a global issue that involves everyone. Merci, thank you, and enjoy the discussion.
Merci beaucoup, Madame Clark, and thank you very much, Sophie, for setting the scene for the conversation we're about to have on the pathways. I've added an S. There are several ways to a decarbonizing industry which contributes to around a quarter of global CO2 emissions. So good morning, everyone. My name is Charlotte Kahn, and I am delighted to moderate what I'm certain will be a very engaging and very important conversation on this new global green industrial revolution. Its complexity, its challenges and opportunities, the role of innovation and technology to accelerate change, and how this transition will have to be a just transition, an inclusive transition. And given the huge costs involved, who will pay for it? As a reminder, UNCTAD predicts that achieving the energy transition will cost about $5.8 trillion every year from this year to 2030. That's $6 trillion a year. So I'm joined today by 4 leaders with first-hand and vast experience of the challenges faced by the industry during its transition journey. So please welcome Nicolas Notebaert, the CEO of VINCI Concessions, Arnaud Pieton, the CEO of Technip Energy, Olivier Scalabre, CEO at BCG France, and Jérôme Stubler, CEO at Equans. And please join me in extending a warm welcome to them. So we have a lot to cover in less than 45 minutes now. So let's get started, and I'll turn to Olivier Scalabre to start with for the big picture. What are the key levers of the transition for the industrial sector? Is it technology, regulation, more regulation, better data, more data, metrics, manpower, woman power, new skills, more political willingness and global collaboration? Probably a little bit of everything. There's no shortage of targets, many public and publicized good intentions, But the big question is, do we have the right tools?
Thank you, Charlotte. First, I would like to highlight the fact that industry needs to solve a carbon challenge, but they also need to solve the planet challenge at large. So we talk also about biodiversity, water, fresh water, and so on. So I think most of the industry is moving also from carbon to nature solutions. When it comes to carbon, the equation is simple. We have 53 gigatons of carbon to remove by 2050. And basically there are two kind of levers in order to achieve this. The first bucket of levers are solutions that exist today. And the good news is that they account for 60% of this reduction. So we can remove 60% of the 53 gigatons with those solutions. And basically there are two of them. The first one is changing behaviors, changing practices. In factories, you remove waste, but you remove carbon as well. And this is basically 10%. And the remaining 50% are technologies that exist today and that we need to scale. So we talk about wind, we talk about solar, we talk about building efficiency, we talk about data and so on. So those solutions exist today. The challenge is to scale them as much as possible. So in industrial buildings, only 7% of them have adopted building efficiency tools, right? So energy efficiency tools. The second bucket, which account for 40%, the remaining 40%, are solutions that do not exist today. They are either at development stage, demonstration stage, or prototype stage. Demonstration, so we talk about carbon capture, we talk about hydrogen, be it electrolyzers or fuel cells, and those technologies basically are in a technology readiness level of let's say 4 to 6. And then down in the technology readiness curve, you have technologies that are at prototype phase. And those ones are direct air capture, the nuclear small modular reactors, synthetic biology. And so the rule of the game for this remaining 40% is time to industrialization. Because if we follow the same development curve for those technologies as the one that we have observed, for solar and wind, will be too late. In order to meet the 2050 challenge, we need to be 5 times faster in the adoption curve of all those new technologies. And as you said, a lot of commitments have been made, but actually plans are not robust yet. If we look at countries, only 30% of the carbon reduction are tackled by net zero plans from countries, from nations. And if we take, the largest 1,000 companies, industrial companies, only 20% of them have a robust plan to converge to net zero. So a lot of ground to cover yet.
Thank you very much. It's a rather sobering start to our conversation to hear that we're making plans for 2050 and that most of the solutions do not exist yet when we've got less than 10 years, according to data scientists, to reduce climate change to the 1.5 degree increase we are targeting. I'd like to hear from Technip now, if possible. We'd like to hear the different solutions, because there are so many of them, to decarbonize. What do you decide to focus on? What's your strategy to decarbonize currently?
Well, I think the introduction was kind of spot on. What we are, as a company that is an enabler to the energy transition, in the sense that we are scaling up solutions to decarbonize and deploying them at scale for our clients and countries and municipalities and energy companies. We have a unique position to observe what is going on. So what is interesting today versus 2 or 3 years ago is the demand. What is it that we are being asked at the moment? 3 years ago, I'll be honest with you, any large energy company, LNG play, etc., they just wanted the same copy-paste, cheapest, So they still want it cheap today, but in all cases, 100% of the cases, they're asking us for the low-carbon option. That was not something that we were asked a few years back, a few months ago, but now I would say systematically, our clients, regardless of their nature, and the nature of the customer is changing. We went from, most of our customers being energy companies or chemical companies to now having municipalities, airlines, sea freight companies and the rest. So it's the landscape is changing, and all of them are now inquiring and asking for the solutions. So what are those solutions? The important thing is we cannot oppose the solutions. We cannot enter into a debate on whether carbon capture is good or bad. We cannot oppose the solution. They will all be important. Carbon capture is important and sequestration is important. Low carbon hydrogen is important. Energy efficiency is important. So for us at scale at the moment, we are focusing on what is mature. So because it's about winning I would say the short to medium term for now. And at the same time, we're investing for the long term. So short to medium term, it's carbon capture, pre or post combustion. And there's no one size fits all there either, whether it's low concentration, high concentration, pre or post combustion. You need to be able to deploy multiple technologies to have the answer to the industries. It's about energy efficiency for sure. It's about electrification for the traditional thing, because the medium term will be won, I would say, through more mature technologies, not the ones that are TRL 3 or 4. That's more longer term. So we need to really accelerate with what is available medium term in terms of maturity. That we are being asked to do. Okay, so that's, I would say, the glass half full, if I may, because from where we were 2 years ago to where we are today, nobody is ready to forego profit for environment yet. The scorecard has not changed, but at least the inquiries are there. Systematically, we are being asked for the low-carbon option when it comes to an infrastructure and an architecture for an infrastructure of the future. So medium term is what's mature, longer term, green H2, e-fuels, etc., etc. But it's all in the pipeline.
Thank you very much. Now, Nicolas Notebaert of VINCI Concessions. VINCI Concessions is not a pure industrial player as such, but because you manage infrastructure, but you are a key player in new mobility and green mobility. Tell us more.
Yes, let's first set the picture together. Human beings are moving species. Since 1 million years, people move, and I'm sorry for the ultra-conservatives in the room, migrations are going to go on. It is a fact for all humans for life. So mobility is a key emission maker of greenhouse gas, approximately 15% of greenhouse gas effects. We need to be scientific based. And we hear so much about it because it's going to grow. The share of mobility is going to grow because human beings are moving. You hear a lot about aviation. Aviation is just 1.5 of these greenhouse gas emissions, but it's going to grow even more. So first we need to set the picture how to keep people mobile, moving, while it creates more and more emissions. First, I'm talking from the infra. Very big. We are the first private infra actor in the world. London Gatwick Airport, for our Canadian friends, Prince Edward Island Bridge, or Fredericton Moncton. So we have various assets. What is the common facts about these assets? First, mobility is not something from the super rich. It is the wrong phrase. It's not business people taking planes. It's going to grow with growing middle class in developing countries. Countries which are big with mountains, not reachable by high-speed trains, for instance. So we don't need to think the transition as very rich people in small countries without mountains, with what we did in France or Japan. That's why we need to work with technology to change mobility. So what do we try to do? And I will develop later on. First, to take care of the infra. An airport is a city. So we need to work about heating. We reduce the energy for the heating. You reduce the bad electricity, so you make the transition to green electricity. You put EV charging both for your customers, car parks in airports or in the highways. You produce a lot of solar energy in the infra, because an infra is a sort of dead body, so you have a lot of space to make solar panels. So we have a 1.2 gigawatt hour production plan. And if you do all of this in the infra, you set the example, because naturally the next step is to say, what do you do for your customers? And so first, do it by yourself. Try to set the example in infra. Secondly, we are the first one, we introduced landing fees modulation to create bonus malus for our customers, so that you pay more if you are more carbonized as a transportation actor, and you pay less for the use of the infra if you are using less carbon. So we have this type of tools to incentivize, but as my colleague from Technip said, we also invest in all solutions. We don't oppose sustainable aviation fuels, which is the solution of today, and hydrogen-based planes, which will be the solution of tomorrow. And the mix will evolve, but as my colleague said, we need to work with the transportation actors in all solutions, so to keep mobility and to have all phases. We'll need green electricity for electric cars, we'll need hydrogen for heavyweight transportation, we need SAF, we need hydrogen, work on all solutions along with transportation. But first we set the example in the infra, and then we help our customers to decarbonize their use.
Thank you very much. We'll talk later on about the need to create new ecosystems in order to deliver the transition. Jérôme Stubler, I'd like to go back to my initial question, really, the key levers of the transition from your perspective at Equans.
Thank you. Just a few words about Equans, because we are one of the biggest unknown company. Equans is 100,000 people. We are a spin-off of NG. We merged with Bouygues in order to create Equans. We are 96% in Americas and in Europe in serving the energy transition, digital transition, and industrial transition. So to your answer to your question, I would like to start with something. The increase of temperature will not be 1.5 degrees, will not be 2 degrees, will not be 2.5 degrees. I believe it will be around 3 degrees. I'm not just willing, to make this seminar negative, but realistic. Today, there is absolutely a full correlation between the GDP and the the CO2 emission. In fact, we went through 3 phases. Phase number 1, let's say the year 2000, people understood that the planet is finite. That was the sidderation phase. Phase number 2 has been the fact that the energy company have started to move their shift to renewable energy. And we see huge shifts, huge change in their business plan. And we are participating to that in wind turbine, nuclear, which is coming back, in the solar. The level of investment which is required is far beyond what we do today. Today we are just providing decarbonized energy at the scale of only the requirement of additional energy. So we are not at scale. And now we are starting the phase number 3. And the scale of the phase number 3 is massive. Is the usage of decarbonized energy by all the company. What does that mean? That means mainly electrification. Electrification of transport, electrification of the railway. It's simple. It is accelerating in many countries. Acceleration of the EV vehicle. You see the huge transformation. We are providing solution right now to gigafactory of battery. We are putting thousands of plugs into the street. And the change is going to be massive. The next change which needs to happen, and for that we need to have standard in Europe, is a change to decarbonize the highway transportation of trucks. The solution is there. It is catenary. which is the most efficient and known solution, which is used for 100 years, and we can decarbonize the transport of trucks. We have done 2 lines, one in Germany, one in Sweden. We can do that. It could be massive for North America. The second element is decarbonization of building. Decarbonization of building is also something which could be easy. Of course, it is changing to heat pump, having heat pump which could divide by 3, 4, 5, sometimes 10 the quantity of energy which is used to heat and cool a building. The solutions are there. It's just a question of putting them at scale and using a free energy, which is the geothermal energy, which is just below a building. And then in industry, again, the first element is to use the fatal heat, which is waste in many of the industry. I can tell you, when we enter, where our specialists are entering into any factory, almost any factory, we find between 10 to 60% of free heat, which is going to the birds. So by capturing this energy, some of it, and reproducing and recollecting that energy and putting it back to the process, we can make massive change. So the solutions are there. It's a question of scale, but the scale needs to be spread massively. And the actors are the companies.
Thank you. I had a question around metrics. And measurement, very important, because it's hard, especially hard for the industrial sector to do that, given how complex and large your value chain is, because only 10% of companies can measure their carbon emissions. And it's the basics, isn't it? So how do you reduce your carbon trail or footprint where you don't even know what it comes from? But we're going to skip that question because we're running out of time. It's just a point I wanted to make. I want to move on to the key enablers. You've mentioned hunting for waste, really, being more efficient in the way we function. And we can do that by harnessing technology. So we've had a kind of first wave of digitalization with IoT, analytics, smart data. And now we've got the very much hyped Gen AI. Okay, so what should we make of it? And my question really is around the use of emerging tech in order to accelerate drastically, massively, this transition. Arnaud at Technip, do you have any examples of that?
So yes, we do. I will disappoint you slightly. It is part of the priorities, probably not the number one in terms of if you want to take carbon off the atmosphere. Yeah, great to talk about Gen AI. It's an enabler. But what Jérôme mentioned a bit earlier is, I would say, more important to be pragmatic than Gen AI. So Gen AI is something I think all industries are adopting. You need qualitative data in order for Gen AI to be in return qualitative as well for your business. That takes time, so we need to clean the data, have the right architecture, etc. Now we are using Gen AI as a company to, for example, decarbonize and gain efficiency around logistics, shipping, short on the routes. So it is already used for a company like ours, which is technology and the architecture, the architect of the energy transition and the energy infrastructure. So we are using it to get better, and therefore as a result we're saving carbon and we're burning less fuel and everything is more optimized for sure. Okay, but if I want to be a little bit radical and pragmatic, yes to a Gen AI as an enabler, but in order to achieve what Jérôme described. Okay, so the bulk of the carbon is not going to be taken off the air by Gen AI. It's other things, and Gen AI is an enabler to that, but only an enabler.
But I can say something. I agree with Arnaud. Today, AI is something which is not really used in order to save energy at scale. We start to do a few things. We just do what we call intelligent, smart building, which is using AI in order to predict a little more where we can heat and cool depending on the weather forecast. What will be at scale? And I'm using what has been said previously, but the Internet of Energy. there is something which is changing. There will be, in fact, two networks of energy. A network which is the network of electricity. And what is the change in what is coming in the network of electricity is the fact that up to now, when you produce an electron somewhere, you use that electron at the same time. What is coming is that we're going to store electron on battery. And this storage needs to be optimized, and for that it is sharing of energy at a scale which is at the scale of the loss of energy by plates. And for that you need, of course, AI in order to introduce this level. And there is another scale which is coming to come, which is the Internet of thermal energy. What does that mean? When you have a factory which is using a process with 1,000 degrees, okay, you have a huge thermal inertia. Can we use that thermal inertia at the level of the factory? Yes. Is it optimized? No. Can we do that at a larger scale? When you need to have 90 degrees at the city level, is it optimized? Partially with the district heating. How we are in terms of having been progressing in this energy sharing? Let's say in Europe, 5–10% what it could be. North America, 2–3% of what it could be. So this level of Internet of energy, electrical and thermal, will be progressively connected. And for that, it is a huge effort which needs to be made in terms of interconnectivity of all that to make the optimization. And for sure, there are major savings to be made by this interconnection.
Thank you. I believe, Nicolas, that you wanted to follow up on this.
Yeah, yes, I will enlarge slightly your questions to how innovation from the private sector, from business, can help meet the target. Give you two examples. The agility of the concession model will represent. Traditionally, you need to have, let's say, 50 years. You build terminals, you enlarge highways, you build, and then you get more and more people. Our role today to switch the model to have probably a little bit less volume than what was predicted, but more quality, and to switch from building a lot of concrete, I would say traditional concrete, to more solar energy, more hydrogen facilities. So this switch is allowed by our financing model because unlike states, we don't have annual constraints of budget, and we can make this switch between traditional capacity to energy facilities. And it goes with the financing because we get with this type of solution, as you know, green bonds, new types of financing. That's the first idea. Financing and concession is very agile to address this transition. The second thing is technology. I give you an example. We waste a lot of carbon with the people waiting at toll plaza in highways. We invested in a Texas company which is #1 for electronic toll collection. So technology allows now reading the license plate or even seeing how many people there are in the cars. It's very easy with technology not to prevent these people waiting at the toll plaza. So this is how innovation and technology can save carbon with the fluidity of the tolling, for instance, that we have in Texas in our VINCI contracts.
Thank you. Olivier, maybe on the point of innovation, emerging tech, innovative strategies to decarbonize?
Yeah, I think the point I wanted to make also is on this regard is the risk that we have, because we talk about technology as a key pillar of the pathway to decarbonization. But if we look at, and we talked about solar, wind, battery storage, electrification, hydrogen, you name it. And actually, those pathways to decarbonization, they are in the hands of some countries like China, like Indonesia, like many countries. And so we are shifting a dependency, from oil producers to other type of dependencies. So if I take, for example, solar panels, batteries, all those technologies, today, 85% of them are made in China. You take the components. So you take a wind farm and you take the blades, the nacelles, the towers. 85% of those are made in China today. And if you go down to the raw materials, then for electrification, then you have, cobalt, which is in Congo Republic. You have nickel, which is in Indonesia, for 80+%. So I think there is a huge risk is that today those solutions to decarbonizing Europe are in the hands of some, let's say, autocratic countries, and that are creating a big dependency. So for me, there is a real call for action to relocalize, those technologies back in Europe, in order to increase our sovereignty. And that's an important one because it will create, employment. It will create growth. We can see it already. We talked about Dunkirk, and all the mega factories that are being built back in Europe. It's 2.5 million jobs that are going to be created, only by those mega factories in Europe. And green technologies, those green techs, it's 25,000 billion euros of growth that is going to be produced, with those technologies. So having them back in Europe is very important. It's also very important because it has an indirect effect on all the industry. If I take a steel factory, if I take a factory producing aluminium, cement, whatever, today decarbonization, being able to decarbonize those industries is super important. So if you are the owner, the industrial manager, of a steel company, for example, you need to decide where you are going to modernize and where you are going to open up new green facilities. So competitiveness is your number one criteria. If you decide to do it in Europe, in France, or whatever. Number two criteria is I am able to decarbonize because there are ecosystem of green technologies, because there is regulation. So if we are able to relocalize those green techs in Europe, it will have an indirect effect on relocation of the whole industry. And this is not an easy one because in front of us we have the US with the IRA, which is throwing a lot of money. So we talk about $460 billion, injected to basically relocate, those technologies in the US. And they are using something which is very different from Europe, which is incentives. And today, if I take, we talked about e-fuels for aviation. So today, it's 2 times less expensive to produce them in the US because of IRA than to produce them in Europe. So there is a big call for action. And on the other side, China is moving very fast. China is the leader of decarbonization today. And they are throwing, $800 billion, in wind, in solar, in hydrogen. And today it's 50% of the electrolyzer install base is actually located in China. So it's important to relocate all those technologies, but we have big competitors in front of us.
Absolutely. It's getting a bit political, isn't it? So 2 important points: sovereignty issues, of course, but the fact that this transition is also a fantastic opportunity for Europe to reindustrialize. I was wondering if you had a take on this or views on this more political aspect of the transition. Nicolas, maybe?
Yes, I add with my colleague, Europe, which was built with a way of uniting rules, is it at a strategic crossroad. Whether it goes, as the US did, in simplifying and adding carrots to help everybody, not only the companies, the people to decarbonize, which is what the US tried to do. I don't say it's the only way, but it's one way. Or what the French government just did, which is a strategic mistake to tax, because taxing is the worst thing to do, because you tax a sector, infrastructure, which needs to make the transition. So you add a burden I'm sorry, it's not the French government which is going to decarbonize. It is the companies, it is the infra, it is the cars, it is everybody. I mean, all the chain is going to decarbonize. So the worst things to do is to tax. The best is to add ways to self-invest locally, as my colleague said, in the decarbonization. So I would say now it's time to switch and to have a European model where we really help setting the right solutions, which is green hydrogen, e-fuels for the planes, going on finding the innovation solutions to work about engines, about cars, about planes within Europe. That's the jobs of tomorrow. We'll talk about human resources. Engineers have the fantastic roadmap today to work in Europe. Working in planes, in engines, in cars, and producing and thinking of them, designing them here, is the key challenge of tomorrow. And our job in the companies is to convince the government that it's not just a sort of magic matter as industry. It is because they help all the sector to decarbonize with local solutions that we'll be able to meet the target and to do it at home, particularly in Europe.
There is a big change. If I take just the example that you gave on carbon capture, in Europe, what we do is we create rules and regulations. So we have the CBAM, entering the market. And so that's the lever that has been pulled. If you look at the US and with the IRA, there are two subsidies for the manufacturers of carbon capture systems, and for the factories that are going to use this system, because they can remove directly from their tax $60 per ton captured. So it's like impôt crédit recherche, in France, but applied to carbon, where any time you remove 1 ton of carbon, you remove $60 from your tax, slip. So the impact is massive, and I think the case for change for Europe is huge in order to cope with this.
Thank you very much. Going back to the point that Nicolas was making, two important things here, which I promised to address in my introduction. It's the issue of human resources, skills, talent. It's very acute in your sector, in industry. It's hard to recruit engineers. It's hard to recruit people in construction normally, but even more so when you're trying to transition. So you need that workforce, but you also need that green transition knowledge. So how do you go about it? How do you attract the right talent? How do you reskill, upskill your workforce? And how much of a problem is it for you currently? And solutions, of course.
Yeah, it's absolutely crucial. So, first of all, there's a bit of a golden age for engineering. Let's be, if we want to be honest with ourselves, it's great to be an engineer in the current era, at the current moment, because there's a lot to invent, there's a lot to deploy, and so you can really have fun doing what you're supposed to be doing as a job and for the career that you've picked. A lot of the engineers that were pertinent, I would say, in the old energy system or the current energy system are also pertinent in the new one, because it's about the molecule. We talk a lot about hydrogen, but it's not a new molecule. We talk a lot about ammonia. It's not a new molecule. We talk a lot. It's old chemistry, right? But applied to new domains and new applications. So I would say when we look at the population of engineers, we have 15,000 people in the group. About 2/3 of that are engineers. On any given project, 80% of them, I would say, are pertinent with their current skill set. But there's 20% of expertise for those new applications. And for that, we need to prepare that workforce. So we've invested massively. So, for example, at Technip Energies, training represented this year 16 hours per head per year. Next year, it's going to be 25 hours. 2025 is 40 hours. So it's a full week of reskilling training per head in the year. So it's a massive investment. It's a cost. Now, it's also being recognized by those who are investing in the company, if I may say. So the shareholders, they feel reassured that we are actually doing that. Okay, so it's an investment, but for the better. So it's true for the youngsters, and it's true for the more experienced people. Those who have 10, 15 years to still give to the company, they need to be up to speed with what is happening as well. So the investment is across the population, not only, you're young, therefore you're an apprentice, you need to learn. No, actually, if I'm 55, I'm also an apprentice in some of the space that is going to be new tomorrow.
But for us also, it's totally crucial. What we like to say is that, if I look to the company growth, we are growing quite fast right now. The company growth is not linked to the market demand. It's linked to our capacity. It's linked to the number of people that we can put on project. As simple as that. So we need more engineers, and we need, as you said, it's a golden age for engineers for sure, for not a decade, for 3-4 decades. They have to reinvent, most of the industry need to reinvent themselves in the way they produce, in the way they use energy. And we need also to scale the number of technicians that we have. What we try to do, and in fact it is a massive change which is coming, we start to explain that our electrician, our mechanical staff, our robotics guys, our digital people, have very modern skill right now. When you're an electrician, now you are at the front of the page, and we try to make them proud of doing what is in fact the motto we use to recruit, proud to make it real, proud to be an actor of that transition. Come to us, we do have a real job in which you will do real things, which will really serving the planet. As simple as that.
They are part of the solution. We are part of the solution.
Exactly.
Yes, we recruit and we keep very easily people telling the truth. We said, do you want to join us to design, to build, to finance the infrastructure anywhere in the world? Because as Jérôme said, we have a single planet. So allowing to develop a company's protocol about decarbonization anywhere in the world. And for us, it's Brazil, it's Mexico, it's Japan, it's UK, as France. It's a challenge, and it's a challenge of the generation. So do you want to be part of this challenge, working globally to be part of the solution? And that means the forgotten part about the KPIs. With a company with KPIs to decarbonize and be better than the Paris Climate Agreement, we'll have our zero net emission airports as soon as this year in Toulon, 26 in Lyon, 2030, 20 years ahead in European Union. So to set an ambitious target and to play it globally against our competitors. We are not the same values as our Chinese competitors, our other parts of the world. So let's be part of the competition our way with our values, where the top value is fighting against climate change through our activities. I think that's the right way to tell the story to the young generation, and it works, and we need to go on and go on to be part of the solution with them.
Just the numbers is 7 million. There is a 7 million workers and engineers gap to deploy all those technologies, either to engineer them or to deploy them on the ground. And this ranges from engineers back to blue collars, because welders, for example, is definitely a key areas where we have skill gaps. And so for me, the cooperation, and I think it was mentioned in the introduction, the cooperation between industries and universities in the same ecosystem to train and to generate this new generation of talent is super important. And you talked about Gen AI. This is where Gen AI can make a big thing as well, have a big role, because the way you can learn and the speed of learning is actually multiplied by a factor of 15, by Gen AI. So it could be a way to train, the new generation as fast as possible.
I agree. I mean, Gen AI for knowledge transfer is extremely powerful.
You may have noticed that we only have a few minutes left on the clock, and yet we had so many different topics and themes to discuss and touch upon today. But going back to another gap, it's that of finance, money. According to a BCG study, there's an investment shortfall of $18 trillion out of the 37 needed to finance the transition by 2030. So this will be my last question, maybe. Who will pay for the decarbonisation of the industry? And what role can the financial sector play in this?
As always, everybody will pay. So the question is how make it the most efficient. I don't think, since the Soviet Union collapsed, a ghost plan and a tax is the best way to succeed. So first, not raise the tax and just make a plan. I mean, that never worked. So first, try to use more carrots than sticks to allow the solutions to emerge as soon as possible, because it's not only the target, it's the time that saves the planet. And then how to monitor in our mobility the lower possible increase of cost. Why? Because we need to make everything socially acceptable. For us, it's not a surprise that mobility increase of cost is creating a lot of social unrest. Not only in France, remember the yellow vest just for diesel tax, everywhere in the world. So we think if the states do not invest with us to make and monitor solutions which are cost effective with time, and just put tax and it will be higher price, they will put ahead the problem, and if there is social unrest, it can block for a decade the solution. So keeping the path, as the rector of the Laval University said, between all pillars of ESG and not only environment, for us, being social and societally acceptable is the way to speed up the process. And if the governments forget it and try to push and to say, oh, it's easy, we can tax this and this, they will face the social unrest, which can be the biggest danger for us to develop environmentally friendly solutions.
Thank you very much. To our three other guests, I want to orientate the question slightly on the issue of financing, of course, but also that of the just transition. Olivier.
I think here time is our best ally, because, you know, there is the famous experience curve that we invented, you know, at BCG long time ago, which says that, you know, at the beginning of the experience curve, the cost per unit is high, but the more you produce, you know, and the lower the unit cost becomes. And so today the green premium, which is the delta between, you know, the difference between the carbon technology and the green technology, is high, right? It is high today. But when we would have gone down through the experience curve, this premium will be 5–10%. And this is something which is, I think, socially acceptable. And so it's a race. We need to go down the experience curve as fast as possible. This is why we need to inject capital. This is why we need the talent, because as soon as we would have go down this experience curve, then the green premium would be acceptable by the population.
Thank you. Jérôme?
Two very pragmatical answer. When we go to an average size company and we look to their decarbonization plan, the first 30% of reduction of carbon dioxide have a return on investment which is less than 5 years. So it's self-finance. The second element, we have gigawatts of solar finance waiting for permit. So in that regard, the problem is not money, it's permitting and connection.
Why is it taking so long? We won't have the time to address it right now. Arnaud, Pieton.
Not just transition, but I think there's no transition without the consumer paying. So through the plane ticket or the cost of electricity and the rest. So it's about scale, and it's about that's the only scale will bring the cost down. So we need to accelerate, scale up, and just deploy at scale and not be obsessed by the micro thing that people like to talk about. It's what matters is scale. That's where you get the cost down.
Let's just get on with it, shall we? Thank you very much. And please join me in thanking our guests. We have Nicolas Notebaert, the CEO of VINCI Concessions, Olivier Scalabre, CEO at BCG France, Arnaud Pieton, CEO at Technip Energy, and Jérôme Stubler, CEO at Equans. And thank you for your attention today. Thank you very much.